Now in this video, let us see and learn what are the properties of Laplace transform. So we have basically two properties of Laplace transform. First is Laplace transform with a constant and a function, which is always is equal to k into Laplace of f of t. Second is if there exist two functions plus or minus g of t, then the value will be equal to L of f of t These are the two properties of Laplace transform we are going to discuss now. One is when a function is multiplied by or it is given with a constant, so it's always equal to constant into Laplace of f of t, and if there is a combination of two functions given in a Laplace form, then we need to individually Laplace them and assign the plus or minus value. So first let us prove this first property, Laplace of k into f of t. Now from the basic definition of Laplace, we know that Laplace of f of t is equal to integration from 0 to infinity e to the power of minus st f of t dt. For our assumption convenience, let us assume k into f of t as f of t for our assumption of for our convenience. Now if you find the L of f of t, then according to the definition, value will be L of f of t is equal to integration from 0 to infinity to the power of minus st into f of t. Now integration from 0 to infinity e to the power of minus st f of t, in place of f of t, k into f of t, because for our convenience we have taken f of t, k into f of t as f of t. So according to the definition we have written this, and we are replacing f of t by k into f of t here into dt, which is equal to, from the basic definition and basic rules of integration, we know that integration of any constant into function is always equal to k into integration of f of x. We are taking out the constant from the integration we kept outside, so this is the basic rule. So the same thing, k is a constant, we are taking out here k, integration from 0 to infinity to the power of minus st f of t dt. This is the definition of Laplace. We can replace this by L of f of t, k remains here, so L of k into f of t is this. Hence this property is proved. Now let's prove another property, that is Laplace of f of t plus or minus g of t is equal to Laplace of f of t plus or minus g of t plus or minus Laplace of g of t. We need to prove this. First let us consider for our convenience, take this whole function as f of t. Now according to the definition of Laplace, Laplace of f of t is equal to integration from 0 to infinity e to the power of minus st into f of t dt. Integration from 0 to infinity e to the power of minus st. In place of f of t we will take this f of t plus or minus g of t into dt. Integration from 0 to infinity e to the power of st into f of t to dt plus or minus integration from 0 to infinity, multiplying these two terms with this, plus or minus e to the power of minus st g of t dt. This is of the form Laplace of f of t sin Laplace of g of t, Laplace of f of t plus or minus g of t is equal to individual Laplace. So the second property is also proved. So these two properties are the basic properties which are using in upcoming problems. One of like this and another is of like this. Thank you.